And our next speaker is Pedro Mallol from the La Fe University and the Polytechnic Hospital. They're part of our very new BIMCV Node. So please, Pedro, take it away.
So now I'm trying to explain a little bit on how you can automate your data extraction for your projects, because we already have a lot of European projects in our research group, and we work with a lot of kind of data. We work with imaging and also with the clinical data related to those imaging. And sometimes we are working with a huge amount of data. So we decide to create some kind of pipeline just to automate the extraction of the data, because in that sense, it will be pretty straightforward just to complete all the projects and so on. So first of all, I think it's important to mention the structure of the node, because we are a research group, but we are also participating with, we are very related with the hospital. So we are the biomedical imaging research group, and within this group, we have the experimental radiology platform and the medical imaging clinical trials unit, that we are part of the research institute. And also we have a medical imaging department that is part of the hospital, La Fe Hospital. That means that we are a research group, that we are very close to a hospital. That means that we have access to a huge amount of data. Of course, we need to fulfill any criteria. We need to the approval for all the ethics committee and so on. But once we achieve all these documents and we do that, we can have access to those data. So here, the fact is that we have in the hospital a data warehouse, a research data warehouse. That is the key of this point, because we have all the data that has been gathering within the hospital in a daily practice basis. This is what we call the real world data. And then we perform an ETL. The ETL stands for extract, transfer, and load. This is a process, maybe you will know, of course, but we perform this process just to centralize the data. We take all this data, we centralize in the same place. This place is the research data warehouse. And within this place, we have the data now in the pseudonymous way, or fully anonymized, depending the method of the project. And then we have another ETL process. This other process standardizes the data. In this case, we work with the CVN. This is a well-known common data model that is worked for clinical research. And at the end, what we have is all the clinical data that we are gathering in the hospital in the same place and with the same format. And this is a very straightforward just to perform our research. So I want to focus in the 10 million project, because this is the use case that I want to use just to explain you how to do that. So just a brief summary of the project. The 10 million project, this is a European project that we are coordinating in La Fe. The objective of this project is the creation of an European repository of medical images with the most relevant associated clinical data. That means that we will have medical images and also all the relevant clinical data associated to those images. And this repository will be for prostate, breast, colon, rectum, and lung cancer. We expect over 15 million of images, and this repository will be centralized and interoperable with other repositories in the European Union. Of course, the access control will be compliant with the ethical and legal criteria, and we will have the data. All the data will be created, annotated, and also harmonized just to perform a good quality of the data. And last but not least, it's very important to mention that this repository will have a high computing resources, because we want to train and validate our AI models in the platform. So as you can imagine, we are expecting a huge amount of data. So we start with this automatic extraction of the data. So we have several partners that we are data holders with the clinical with the data, also clinical data and image data. We are one of them. And this is more or less the structure. This is the architecture of this process. So I don't expect that you understand just right now this slide, because this appearance is very huge, but I'm going to split this slide and I'm going to explain a little bit one by one. So at the end of the presentation, I hope you understand more or less. And of course, if you have any question, you will have in the chat, or you will have my email. So the first thing that we need to do is to extract the data from the hospital. So this is the first step, but this is a very important step because we perform the CTL. You may know this information that is in the hospital. This is the real world data. This data is open. That means that we have all the names and all the sensitive data from the patient. So we need to take this data and we need to perform some transformation in the data. One of this transformation will be the pseudonymization of the data. Maybe we are fully anonymized, depending on the project, as I told you before. But we take the data, we extract the data, and you can imagine this data is very heterogeneous because we have the data in every system of the hospital, and they are with their own model, and they are stored, and they are working with several partners. So this data is very heterogeneous. So we need to take this data and start to perform some kind of harmonization of this data. So the first step is to take this data and perform some pseudonymization process. And we start just to check for the data. We delete duplicates, we search for inconsistent data, and if necessary, we delete also the inconsistent data, and we start a little bit to harmonize the data. And this is the first step. That means that we take all the data and we store in this research and the clinical data warehouse. This is now part of the research group of the hospital. So now that we have all this information in the same place, we still have some heterogeneity in the data. So we perform this second ETL. This second ETL is just to take all this information and we are going to transform in a same common data model. And in our case, we choose OMOP CDM, that this is a widespread known common data model used for research. So all this data will be mapped into this common data model. And all the terms that we have within this business intelligence that we call data maps will be mapped, all the terms will be mapped with a specific vocabulary, specific ontology that we decide within this OMOP CDM. So I forgot to mention before, but we perform a daily copy of the clinical data. That means that we have a daily backup of the clinical data from the hospital. That's great because we have an up-to-date data for the search. So at the end, we will have the clinical data all stored in the same place and with the same common data model. That's great because we increase a lot the interoperability of the data, and we can share the data with another groups and with another hospitals if needed. So now that the easy part for the project now is to consult this OMOP database, because now that we have the data in the same format and in the same way, the only thing that we have to do is create a script. In this case, it's a SQL script because this OMOP database is a SQL database, but sometimes we perform a Python script, whatever. We perform a script that searches in this database for the patient that fulfills the inclusion and the inclusion criteria for the project. So that means that finally we will have a data set with the patients selected for the project, but not only the patient, we also have the clinical data related for those patients. So we also have these clinical variables that we want to study in our project. So now the only thing that we have to do, in this case, we also have an ECREF that stands for Electronic Case Report Form. That will be the window where the rest of the partners of the consortia and the rest of the clinicians will see the data of the project. So we take all this data from this OMOP database, we perform this SQL script, and in an automatic way, we feed this ECREF. That means that in the same process, we have all the data, we select the patients, and we check for the clinical data for those patients, and we store this information within this local repository, let's say. So finally, we have this automatic ingestion of the CRF, and this is more or less because sometimes we need to perform some manually identification of some problems, and we need to check for quality check-ins and so on. And this is very important also because sometimes if we see that we can improve something, we can perform this auto-feeding again, this OMOP database again. So this is a win-win process. All the information that we already enhance, all the data that we already gain, this will be reverted to this OMOP database. But it's important to mention that I was talking for clinical data, but what happens with the imaging data? So maybe most of you will suppose that perform a daily copy of a PACS system of a hospital, this is not possible just right now. It's possible, but it's very huge and it's not recommended because made a daily copy of the images requires a significant amount of storage capacity. And of course, maybe you will have problems. You will saturate the hospital communication for sure. So in that case, we act on demand. That means that when we retrieve all the critical data for those patients, we also retrieve this link with the image that we need. For example, in that case, we use the accession number. So we can create a list of accession number, and with another component of this local repository, in this case, is RadioMix label, we can go to the PACS system and perform this query retrieve process. So we got this accession number list, we go to the PACS system, we query within this list, and the PACS system give me the images. So as you can imagine, in the PACS system, I still have in the open data. That means I still have in the names and some sensitive data that I need to delete, or I need to hash, or I need to do something. So within this process, I will pseudonymize the data or anonymize, depending. And we need to make sure that we are pseudonymizing in the same way that we pseudonymize the clinical data, because we need to link the clinical data with those images. And this is what we do, and this is what we have at the end. We have the clinical data and the imaging data, all in the pseudonymized data. And as I told you before, now we start to check for data completeness, we check if the identification of the images are performing properly, and so on. So we start with this data quality that we need. And this is the part that is more manually, because sometimes we need to check something. And in the end, as I told you before, sometimes we improve the use of our database. And now this is the very end part of the slide. That means that when we are sure that the data quality is good enough, we fully anonymize the data, because now the data is going to leave the hospital. So we fully anonymize the data and we send to the central repository. And in that case, the central repository, the child repository, and this is the repository where the users can access the data and can perform the models and can train and so on. So this is more or less a big picture on what we do in this project and what we used to do with the rest of the projects. And I think this is my last slide. And of course, if you want to tell me something, questions or something, you can send me an email or a chat or whatever.